Hello friends, welcome to my channel. This is Thermodynamics part 5. This is for ISRO examination 2017. And this part is important for GATE and IAS examinations also. I will tell you about the relationship between Cp, Cv, gamma and R. Specific heat at constant pressure is greater than specific heat at constant volume because Cp includes boundary work as well as internal energy, whereas Cv includes only internal energy. So Cp is greater than Cv. For non-monoatomic gases, when temperature increases, Cp also increases, Cv also increases. So gamma is Cp by Cv, and here Cv increases more than Cp increases at higher temperatures. So gamma, Cp also increases, Cv also increases, but overall it decreases for non-monoatomic gases at higher temperature. For ideal gas, Cp and Cv versus temperature graph, we know Cp minus Cv equal to R. Here graph will come like this. This is Cp, then here Cv, and gap is R. This is Cp, then Cv. For monoatomic gases like helium, neon, argon, Cp and Cv does not changes with temperature. Does not changes with temperature. This is very important. So gamma also does not changes with temperature. Here graph is for monoatomic gases only. Cp, Cv, then temperature. It will go like straight line. Both are parallel. Here Cp, Cv, gap is R. For non-monoatomic gases, Cp, Cv versus temperature graph is like this. Here at low temperature, gap is more, and at higher temperature, gap is less because Cv increases more than Cp at higher temperature and gamma value decreases. This is only for non-monoatomic gases. Gamma value decreases with higher temperature. Boyle's law graph I forgot to tell you about in my previous video, so here I am repeating. V is inversely proportional to P. So here pressure versus volume diagram. These are constant temperature lines. Sometimes this type of questions they are asking. They will give and they will ask T1, T2 and T3 which one is greater. So here T1 is less than T2 and T2 is less than T3. You remember this graph, PV diagram for Boyle's law. Next, for Charles' law, V is proportional to temperature at constant pressure. Here we will draw temperature versus volume diagram. T versus V. It will come. Here these are constant pressure lines, P1, P2 and P3. P1 is less than P2 and P2 is less than P3. Once they ask this question, which one is greater? So you remember this graph also. This one P3. Then Zeroth Law of Thermodynamics. It is the basic for temperature measurement. Its definition is when a body A is in thermal equilibrium with a body B and also separately with a body C, then body B and C will be in thermal equilibrium with each other. And relationship between the temperature and pressure of gas can be expressed as, this expression is very important in solving the problems. T equal to A plus B into P. Here A and B are constants. Temperature in Kelvin, T in Kelvin equal to T in degree Celsius plus 273.15. For Rankine scale, temperature in Rankine equal to temperature in degree Fahrenheit plus 459.67. And Fahrenheit and degree Celsius relation is T equal to 9/5 in degree Celsius plus 32. We can write it as 1.8 degree Celsius plus 32. In question, they will give this type of relation. T1 equal to A plus B by B into P1. And second case, they will give steam point and ice point, they will give T2 equal to A plus B into P2. This is P2. From equation 1 and 2 you have to solve it and you will get B value. After that you will get A value. Using A and B relation you will find third temperature. Then our first law of thermodynamics. It's also called as Joule's law. This is conservation of energy. Summation of heat equal to summation of work done for a closed system undergoing a cycle. This is valid for both reversible and irreversible cycle. This one also we can write it as this is also important in solving problem as well as theory questions also they are asking. Then low grade energy. Example is heat. It consists of available energy and unavailable energy. Unavailable energy is, example is entropy. For high grade energy, examples are work, kinetic energy and potential energy. Only available energy. Entropy is 0 for high grade energy. Then for a process, this is very important for solving problems. Del Q equal to D plus del W. If we neglect kinetic energy and potential energy, del Q equal to du plus W. This is very important in solving problems. Then PMM1, which violates first law of thermodynamics. No machine which would continuously supply mechanical work without some other form of energy disappearing simultaneously. Here we cannot get work continuously without some other form of energy disappearing simultaneously. Vice versa also not possible. If it is possible, then that machine is called as PMM1, perpetual motion machine of first kind. It violates first law of thermodynamics. You also read the definition of work and heat, internal energy, cycle, path function, point function. These things also you read separately. Then different type of processes, that also you read. Only some basics you read. No need to go for deep. Thank you friends. Thank you for watching my video. Thank you.